Good morning, students. Today we will be learning about velocity time graph. Velocity time graph of a body under the following condition we will be learning today. Very first, when the body is moving with a constant velocity. When the body is moving with uniformly accelerated motion. When the body is moving with uniform decelerated motion, or you can say retarded motion. When the body is moving with non-uniform accelerated motion. Now velocity time graph provide us the following information. Number 1, with the help of the graph, we can determine the velocity of a moving body at any particular point of time, and we can learn the nature of motion by the different graphs. By the velocity time graph, by calculating the slope, we can calculate the acceleration, as we did in our earlier class, that with the help of the distance time graph, we can find out the speed by calculating the slope. We can determine the total distance covered by the body in a given time interval. Now, let us take one example. Velocity time graph of a moving body with constant velocity. If you observe this table, time in second is given 1 second, 2 second, 3, 4, 5 second, and velocity what we are observing in this table, that at every instant of time the velocity is same, that is 10 meter per second. So when we plot a graph, so in that case what happened? The x-axis represent the time and the y-axis represent the velocity. So what happened in that case? If AB is the graph showing that the velocity at every instant of time is 10 meter per second. As the velocity is constant, and you all know the formula, acceleration is equal to v minus u upon t. V final velocity is 10 at 6 seconds. Initial velocity at 1 is 10 seconds. So change in velocity is 0. So acceleration, change in velocity upon time, that is equal to 0. But as the object is moving with some velocity, so it means that that object must be covering some distance. So how to calculate the distance? If I draw a line, you can observe this blue line BC. In that particular case, what happened? That OC is representing the time, thus AB is also representing the time. OA velocity, BC velocity. So as we know that distance covered is equal to speed into time. What is speed here? Speed is OA and time is OC, right? So in that particular case, OA into AC, that is the length into breadth, and that is the area of rectangle. It means that the area under the graph AB is giving us what? Is giving us the distance covered by an object in a particular instant of time. Now, velocity time graph of a body moving with constant velocity. Again, I have taken one example. Time 0, 1, 2, 3, 4, 5, and velocity is 0 meter per second. And after every 1 second, the velocity keep on increasing by 5 meter per second, and thus finally after 5 seconds, the final velocity is 25 meter per second. So from the graph, acceleration, that is the change in the velocity upon time. And this change in velocity, if you see the perpendicular, that is nothing but the change in velocity, because that line is parallel to the y-axis. So change in velocity 25 minus 0, or you can take 25 minus 10 for this portion, and the related time, that is 5 minus 2. So 15 upon 3, that is 5 meter per second square. So it means you are calculating the slope. So slope of a velocity time graph give us the acceleration. Similarly, if you calculate the area of triangle OAB, that is half into base into height. Half base is what? OB. Height is what? AB. OB is giving us time and AB is giving us velocity, because parallel to the y-axis. Half is a constant. Again the term speed into time is there. It means area enclosed by velocity time graphs, as you have seen in the previous slide, and here also area under the graph, that is the area of a right angle triangle, half into base into height, both giving us the distance covered, or you can say magnitude of displacement. Now, velocity time graph of a body with uniform retardation. It means when we are applying the brakes, in that particular case, what happens? The velocity decreases with time and finally it may come to the rest. In this, at initially when the velocity is being observed, it is at 30, and time after 6 seconds, the velocity becomes 0. So acceleration v minus u. V is what? Final velocity, that is 0, and u, that is the initial velocity, that is nothing but the 30. So 0 minus 30 coming out to be minus 30, and in what time? In 6. So minus 5 per second is square, right? So this negative sign is showing us the retardation. So if the graph is sloping down, right, time after a particular time the velocity becomes 0. So that is the uniform retardation motion. Now distance covered, as we done earlier in our both the slide, area under the graph. Here the area of the triangle. So calculate your own the particular distance covered by the object in 6 seconds using the data given in the table. Or you can simply half into base into height. What is the base? Base is time, that is 6. What is the height? That is velocity 30. So you can easily calculate that distance. Now in this particular, I have shown the velocity time graph of a body moving with non-uniform accelerated motion. Non-uniform means when the velocity increases, when the velocity decreases, when the velocity decreases here stepwise, and when the velocity increases stepwise. So in each and every case, the velocity increases or decreases non-uniformly. So there is not a perfect straight line, and this particular different cases, they are showing us the non-uniform accelerated motion. Why accelerated? Because there is a change in velocity, obviously, but the change is not constant. So that is the case of non-uniform accelerated motion. Students, I have attached one PDF file in which 2 numericals of graph are there. So please go through that PDF file. Thank you.